In section 2.1, we begin to learn about the addition property of equality. And the first thing we want to remember is, what is an equation? An equation is just when you have something equal to something else. That's an equation. And so the next thing we want to remember is what a solution is. A solution to an equation is a value that makes that equation a true statement. So we have a couple of examples here, and the question is x equal to 2 a solution for either of these equations? And so you notice that I have the equation written here, and in the second line I replace my x with the 2 to see if it works. So now we're going to go through our equation and we're going to do the math. We have 5 times 2 is 10. 10 minus 2 equals 8. What is 10 minus 2? It is 8, and 8 does in fact equal 8. Yes, this is a solution for this equation. X does equal 2 in this equation. Now let's look at this one. If we take our x plus 3 equals 6 and we plug in a 2 for x, we see that 2 plus 3 is 5, and that is not equal to what's on the other side. So no, x equals 2 is not a solution for this equation. All right, so now I want to talk to you about what a linear equation is. A linear equation is just an equation that when you graph it, it makes a line. Linear has the word line as a root word, L-I-N-E, right here. And so that's all it is. It's when you graph it, you get a line out. So a linear equation in one variable just means you have one letter, one unknown. All right, so our number one rule for equations is that you must keep both sides equally balanced in order to maintain the integrity or truth of the statement. So the addition property says that if A equals B, if we have two things that are equal to each other, and then you add the same thing to both sides, you wind up with an equivalent equation. In other words, it's okay for you to add the same thing to both sides. They're still equal. And the same thing is true for subtraction. If you subtract the same thing from both sides, they are still equal. So adding the same thing to both sides keeps an equation balanced, and subtracting the same thing from both sides does that also. Addition and subtraction are considered inverse operations, and that means that they are the opposite of each other. So if you have something being added and you need to get rid of it, go ahead and subtract. If you have something being subtracted and you need to get rid of it, then you'll need to add. So here's our first example. X plus 2 equals 10. So I need to get x by itself. So that means I need to get rid of this plus 2 right here. This is an added 2. So I'm going to subtract 2 from both sides in order to maintain the balance of my equations. When I do that, on this side, my 2's cancel, leaving x is equal to 8. And then we would just plug that back into our original equation to see if it works. So I wrote our original equation here. I plugged in 8 instead of x, and I checked it. 8 plus 2 is 10. That does equal the 10 on the other side. So let's try the next example. So we have n minus 10 equals 2, and we need n by itself. So we need to get rid of this minus 10. The opposite of minus 10 is plus 10, so I'm going to add 10 to both sides. When I do that, I get n by itself, because these two guys cancel one another. And then I have 2 plus 10 over here is 12. And then I would plug that in to check it. 12 minus 10 is 2. So now I have an equation with fractions. Let's see if I can move that over. So I have y minus 3/5 equals 1/3. I've got to get rid of this guy because I want y to be by itself. So the opposite of minus 3/5 is plus 3/5. So I'm going to add 3/5 to both sides, leaving y by itself. Now I check my right side and I have 1/3 plus 3/5. And obviously I can't add those together because they don't have matching denominators. So I'm going to rewrite those as a fraction with the least common denominator of 15 in both of those. So 5 times 3 is 15, so I've got to multiply on top by 3 also. 3 times 5 is 15, I have to multiply by 5 on top there. So now I just add these fractions. 5/15 and 9/15 would be 14/15. I can plug that back in here to check and see if it works. Okay, so let's try one with decimals. I have x plus 0.4 equals negative 0.5. because I'm adding, I'm going to subtract 0.4 from both sides, and when I do, that drops away, leaving just x, and then I add these together to get negative 0.9. Okay, and then of course we can check by plugging it back into our original equation. All right, and so here's our final example here. I have 2 in parentheses x minus 3, so it's 2 times x minus 3 is equal to x minus 4. So I'm going to use my distributive property, and I'm going to multiply this 2 through this set of parentheses, and I have 2 times x is 2x, and 2 times negative 3 is negative 6. Now I'm ready to move things around. I want to get everything that has x's over to one side, and typically we move things over to the left side that have x's, and then over to the right side I want to move everything that doesn't have x's. So I'm going to move my x's first, so I'm going to subtract x from both sides to make this cancel. Then I'm going to, so I have 2 x's minus an x, that's 1x, and then bring this down. And then I'm going to take this guy over here because it doesn't have any x's. So minus 6, I need to add 6 to make it cancel. So I'm going to add 6 to both sides, making that cancel, leaving x, and negative 4 plus 6 is 2. We're going to plug that into our original equation, and we'll have 2 times 2 minus 3. 2 minus 3 is negative 1. So 2 times negative 1 is negative 2. And then I have 2 minus 4 is negative 2. So negative 2 equals negative 2. This does work.